Hello everyone, my name is Rebecca Smith. I'm a solutions architect working with customers across the energy and utilities sectors at Amazon Web Services. Today we're focusing on how we can improve seismic image processing time, reduce costs, and create a resilient, scalable architecture on AWS. The main challenge of seismic imaging is to produce high-precision images and producing those images at a faster rate. This requires the ability to compute more intensive wave equation algorithms like full waveform inversion and reverse time migration. Other challenges include interpretation and data management. The interpretation of seismic data is complex and limited by the availability of experienced geoscientists, and management of the increasing amount of copies and versions creates data duplication and more administrative overhead on users. To address these challenges on premises, it necessitates that customers amplify their computing power by an order of magnitude to enable the handling of the substantial scale of wave equation algorithms. The significant increase in computational power can often be cost prohibitive. Working in collaboration with AWS partner Seiswave, we're able to improve the price and performance of seismic imaging processing by 5 times with Seiswave RTM software running on Graviton3 processors designed by AWS and an AWS native architecture. Running on AWS helps remove those barriers of limited budget for compute power. Incorporating interactive AI from Bluware, another AWS partner, enables geoscientists to reduce the extraction of complex subsurface features to weeks versus months. Deploying natively on AWS, images can be immediately imported into the interactive artificial intelligence and machine learning interpretation platform that learns on the fly from users' input. You're able to click a few frames, then the AI/ML platform will do the work for you. Combining Bluware's fast technology and OSDU with OpenVDS eliminates the need for data copy and duplication by streaming data just like you would stream a movie. And other users are able to use that same data stream. Keeping track of the latest versions when files are dispersed and duplicated all over the IT infrastructure becomes a problem of the past with Bluware, fast technology, and OSDU on AWS. In this solution, your on-prem production of data acquisition and pre-image processing will then flow into your AWS cloud environment where image processing to the final seismic image and enhanced interpretation will take place. Seiswave RTM on AWS is unique. Let's take a look at the full band fidelity photo image at the top left of your screen. The input velocity model is an ISO model with a constant value of 2,000 meters per second. The left panel shows the input trace, which is generated by the forward modeling in the model with 4 horizontal reflectors. The middle panel is the RTM migration image. The right panel shows the stack result in the middle panel along horizontal direction. By comparing the left and right panels, RTM proves its high precision by accurately restoring the reflector's depth positions and amplitude information. Moving down to the bottom of the page, inversion-based imaging methods have greatly improved the migration quality, especially on the complex formations. For example, the salt boundaries in the BP 2004 model have been clearly delineated through the inversion method, as you can see when I toggle the images. In the last set of images at the top right of your screen, Seiswave RTM can output impedance and reflectivity simultaneously, carrying out the comprehensive analysis of the seismic data, providing detailed insights into the subsurface properties and the potential important locations. Let's take a look at the Seiswave software running on AWS. The environment is similar to a 3-tier web architecture with the front end, back end, and storage. Users access through their application, web app, mobile app, or Jupyter, depending on their role. Through the AWS API Gateway, where we have our Lambda functions running. AWS Lambda is a fully managed serverless compute service that runs code for you without the need for you to provision or manage servers. You can run your code for virtually any type of application or backend service, and Lambda automatically allocates compute power and runs your code based on the incoming requests or events for any scale of traffic. In the front end, you have data cleaning, resulting in a JSON file added to the Amazon Simple Storage Service, or S3 bucket, to store your data in OSDU, a fully managed OSDU data platform on AWS. In the back end, we see the analysis service, migration service, and reduction service, running in 3 separate areas on Amazon Compute Cloud instances, or EC2 instances, which are secure, resizable compute capacity, with over 600 types of instances available. Right-sizing the instances for the required job, we're using Amazon EC2 T2 instances in the analysis service and the reduction service. T2 instances are cost-efficient with burstable performance that provide a baseline level of CPU performance with the ability to burst above the baseline. For the migration service, we see that we have Amazon EC2 P4DE instance types. The P4 instances provide high performance for machine learning training and high performance computing in the cloud with up to 8 NVIDIA A100 Tensor Core GPUs and 400 gigabytes per second instance networking, in addition to other high-performance computing features. Each section of the EC2 instances is also being scaled in and out automatically with EC2 autoscaling. This dynamically increases the number of instances as the demand increases and reduces the number of instances as demand decreases, based on a criteria that you set. Autoscaling also replaces unhealthy instances with healthy ones, providing an automated, resilient, and scalable infrastructure. In between each of the service sections is Amazon Simple Queue Service, or Amazon SQS, a fully managed message queuing service that enables communication between applications even when they speak different languages. This allows for the decoupling of components from a monolithic architecture to a distributed system and allows you to scale independently, offers a more resilient infrastructure, and enables you to right-size your instances for cost optimization and performance efficiency. This means that you can bring the application you're currently using and enable communication with another application with a different programming language in this architecture. Select your compute based on the need of each component and create performant, optimized, and resilient infrastructure that can meet your goals. Amazon SQS requires no administrative overhead and little configuration, working on a massive scale, processing billions of messages a day while providing message durability. Let's take a look at Seiswave RTM on AWS with Graviton 3. Here are some simulated images produced by Seismic. The top row shows Seiswave RTM on AWS with Graviton 3 instances, showing the art of the possible. We have 40 Hz reverse time migration with an overall 1,500 nodes, with the additional key parameters there listed. The bottom row shows the reflectivity. You'll notice at the bottom of the inline and X-line images, there's a line. This line is the SEG logo embedded 15 kilometers down below the salt layer. Seiswave RTM shows the quality of the images that it's able to achieve at a fraction of the cost on AWS. This quality can be increased, but it will also increase your costs. Let's take a look at how Bluware fits into the solution. This is a simplified image of the various steps of how Bluware Fast Technology, working with OSDU and OpenVDS, streams data to your applications, relieving you of the need to duplicate and track versions of your data and reducing the amount of storage you would require over time. In the first section, we have data, the seismic data ingestion and conversion to OpenVDS on Amazon S3, leveraging S3 intelligent tiering for automatic optimization of storage costs. In the second section, we have conversion. Data streaming and transcoding setup happens here, where the seismic files on Amazon S3 are virtually mapped to the local file system on the EC2 workstation where the apps run. Finally, in the last section, applications, we have detection of new files, transcoding, and reingestion into S3 or OSDU. You can connect your preferred applications such as Petrel and stream your data. Now let's see how Bluware Interactive AI can reduce the time to completion of workloads. Bluware Interactive AI is a software application designed to manage all the data science tasks so that geoscientists can apply deep learning to their seismic datasets. Training and making machine learning inferences is invoked by simply pressing a button. Interactive AI's deep learning engine depends on the geoscientist to provide localized expertise about the data and basin. By learning from your interpretation, it suggests incrementally new interpretations as you make your way across the seismic dataset. Outputs from interactive AI can be immediately consumed by the standard interpretation packages and helps the geoscientists capture the true extent of the geological features within their region of interest on both a local and a regional scale. Geoscientists can now shift their focus of critical evaluation instead of the laborious and tedious interpretation and understand the complexities of their datasets. The only end-user requirement for interactive AI is an internet connection and a web browser. By separating the UI and the compute engine, even the most modestly equipped commodity laptops can harness the power of ML. This is a great real-world example of reducing capital IT budgets when moving workloads into the cloud. In collaboration, Seiswave, Bluware, and AWS are working to remove the barriers of entry, democratizing access to high-performance computing and deep learning for every geoscientist in exploration and production. While interactive AI enables a software-based solution to apply machine learning to your seismic, powerful hardware is still required to power the code. Interactive AI was built using a web-based client-server architecture, using Amazon EC2 instances for GPU-intensive tasks like machine learning. With the power of interactive AI built on AWS, you can accelerate insights from hours to days. Thank you for joining me today in reviewing this solution to improve seismic image quality and processing speed and creating a cost-optimized, resilient, and scalable architecture on AWS for high-performance computing.